You may recall from a previous section our equation that we can use for investment problems. The final value of an investment is equal to the starting value times 1 plus the interest rate written as a decimal raised to the amount of time of the investment. Our first question says a person invests $7,000 in a bank account with a yearly interest rate of 6% compounded annually. When will the balance be $10,000? So in this case, the final amount we want to end up with is $10,000. The starting value is $7,000. Our interest rate is 6%, so our multiplier here would be 1 plus 0.06. We don't know what the time is. That's what we're trying to find. We're trying to find how long it will take, how many years it will be. So we'll put x for our exponent. And this is the equation that we would like to solve. So to solve this, we need to get our exponential expression by itself. The first step to doing that would be to divide by 7,000 on both sides. And this leaves us with 10,000 divided by 7,000 equals, I'll leave a little bit of space, and 1 plus 0.06 would give us 1.06 raised to the x. Next, we take a logarithm of both sides. On the left side, there's not a whole lot we can do with that for right now. It's still logarithm of 10,000 over 7,000. On the right side, now we can pull our exponent to the front. X times the logarithm of 1.06. And now to get that x by itself, we would divide both sides by the logarithm of 1.06. And that's going to get x by itself. If we go ahead and calculate the value of that expression on the left side, logarithm of 10,000 divided by 7,000 divided by the logarithm of 1.06, we have about 6.12, just to round our answer to 2 decimal places. So here, if we round that off to the nearest whole number, we would say that our time would be approximately 6 years to end up with that final value that we want. If you would like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. This problem reads, a person invests $2,000 in a bank account with a yearly interest rate of 4.5%, compounded annually. How long will it take for the value of the account to double? So if we start with 2,000 and it doubles, double means we multiply the value by 2. 2,000 times 2 would be 4,000. So here we'll put 4,000 for the final value, 2,000 for the starting value. Our rate is 4.5%, so our multiplier will be 1 plus 0.045, and we're trying to find the time, so I'll put x for the time. Here, our first step for solving is dividing by 2,000. And 4,000 divided by 2,000 is a nice, easy whole number to work with. So I'll go ahead and just write that as 2 equals. And on the right side, again, I'll leave a little bit of space. We would have 1.045 to the x. Now I take a logarithm of both sides. I pulled the exponent out to the front of the right side, and I have logarithm of 2 equals the logarithm, or sorry, x times the logarithm of 1.045. Divide both sides by logarithm of 1.045. And on the right side now, all we'll have is x. On the left side, if I calculate the logarithm of 2 divided by the logarithm of 1.045, here we have about 15.75. Now, since we're compounding annually, it makes the most sense to round off to a whole number. So we'll say 16 years is the approximate time we would need for this investment to double.